Approximately 24 billion shoes produced in 2020. More than $400 billion of revenue generated all over the world. Since the late 60s, most of the more than 300 shoe companies have disappeared and about 30 survived until the beginning of the 21st century. Shoes today are still traditionally manufactured, but 3D printing is becoming more and more popular in this sector. I would like to introduce our guest today, who has recently published a fascinating shoe design called the Cryptide. So he's definitively not a stranger to the shoe designing industry. Stephan Henrich's work is located at the section of Architecture, Narration, Design and Robotics. He runs his design studio with Robot Lab in Stuttgart, Germany. He is specialized in design for additive manufacturing. And thanks to SLS in particular, he has realized projects such as movable chairs and tables, intricate wallets, or robotic infected textiles. Welcome, Stephan Henrich. How are you today?
I'm good. Thank you, Gabor. Yeah, welcome everyone to the little tech talk we have today. As you mentioned, Gabor, the topic today is design for shoes and SLS or additive manufacturing in general. Maybe you saw the Cryptide sneaker I designed lately, printable on an S2 system by Sintratec. Yeah, today I would just let you know a bit more what is important when it comes to shoe design for additive manufacturing. I have 5 points for you. So just let's start with the first one. The first point might look or might sound a bit funny or even a bit obvious when I tell you, but it is very important. And while designing shoes, you might forget about it and then you have a little problem. So when you design a shoe for additive manufacturing, it is for sure not the tiniest item that one can imagine to be 3D printed. It's big, it's 30 something centimeters. So you make sure it fits the build space when you design it. Maybe you have a 42, European size 42 when you design it. You check it, fits in, perfect, in length, X, Y, Z. But what happens when you have a 45? Does it still fit the build space? Also in width, also in height? Be aware of this because it can cause trouble, and then you have to overthink everything, even though it sounds obvious. And yeah. So second up, important thing: profit of the design freedom and the geometric freedom that 3D printing and for most SLS, so selective laser sintering, offers to you. Why? Because traditional injection molded parts, the shoe sole often is injection molded, it has to compete against it. So injection molded parts, of course, you have a mold or molding system that is expensive in the beginning, but once you have enough units per mold, it becomes very inexpensive. Versus in SLS or in additive manufacturing in general, you start off very inexpensively, you don't need a mold. But then the unit stays expensive even though you have a big quantity of it in comparison to injection molding. So you need the selling point, in my opinion, to profit of the geometric freedom, to profit of the design freedom, to be able to get a complexity that allows you to introduce functionality that is maybe not so easy to introduce with injection molded parts.
All right, I see. Stephan, thank you very much, especially as well for the comparison for injection molding. I think that's one of the most interesting topics or production methods to be compared. So what's your top tips that you would like to pass then in terms of design? Is it, the thickness of the walls, or what is it that could cause some problems in this design process?
Yeah, that could be actually my next point. Yes, if you design not only the sole, but the entire shoe, so the upper shoe as well, take care of layer thickness. So a conventional shoe is maybe, or the upper shoe is maybe done in textile or in leather, and translated textile or leather into TPE, so the flexible material that, for example, Sintratec provides, cannot be translated 1-to-1 in thickness. So foresee a bit more material thickness than leather does, otherwise it will break. So really take care of the design guidelines that Sintratec or your printing service or the SLS company that provides the machine offers, and you are safe. Yes, another thing that really is interesting or important to see when you design is that material thickness can steer or manage the softness and the rigidity of the object. So a sole or a shoe is not hasn't the same rigidity or softness in every spot. So you can really design for every specific zone of the shoe a specific softness, and this of course can gradually shift from soft to rigid. This is something interesting when you do it in one monolithic material like TPE, that you can use geometry to steer your softness and your rigidity.
You told me that you had to do 3 to 5 iterations of the shoe that you printed, of the Cryptide design. So what thickness or wall thickness did you started then, and what was disappointing at the beginning and led you to this journey to the end version of the design of the shoe then?
I'm not sure if it's really disappointing, but I had a little experience before in TPE by doing this orthesis part for the wrist, you remember? And the thing I had to learn there are different forces. So the orthesis came in some areas where there was a wristband that was maybe 2 or 2.5 millimeter in thickness in TPE, and I thought that could be then transferred on a shoe design on the upper shoe, but that was not really the case. I had to add some millimeters more, so I think I ended up with a bit more than 4 millimeters, and this gave then the result after the 3rd or 4th iteration, with which we were happy, because durability is of course something that you want to obtain, and therefore 4.5 millimeter might be a good direction to go in.
All right, good. Thank you very much for answering this, Stephan. So please continue. The next tips from your perspective.
So the 5th point is that you really can customize the product in the very sense of the word when you design a shoe for additive manufacturing. Using 3D scanning data of the very foot you design your shoe for allows you to do a very perfect fit that goes far beyond just adapting the shoe size. Is it more 40 or is it more 45, 40 and a half? This is something you can only do in additive manufacturing because it doesn't add any cost per unit once you go for the 3D scanning method.
Good. So let me just please hook in here, because this was one of the most interesting points or most raised questions from the audience as well. So how do you get or transform the scan file into a file that you can work with in the software that you are designing? Because for many people, this is already let's say a deal breaker, how to get these in an STL file that you can design then and change the geometrics to design the appearance of the shoe fitting your personal feet.
Yeah, it's a bit of reverse engineering when you have, like with every scan data, you have a STL file with a mesh that is not very adapted for the process that will come following up. So you have to reverse engineer the surface that you have it prepared to a mesh that is adapted to shoe design. Yes.
All right, Stephan, very important information, very good points. So can you please just summarize those 5 points again, please?
Of course. So first one, make sure the shoe fits into the build volume of the printer with which you want to print your design. Second one, profit of the geometric freedom, because it is one very important selling point for most in comparison to traditional or conventional manufacturing methods like injection molding. Third one, when it comes to translating material thicknesses from leather or textile in the upper shoe, for example, that everyone is used to as a material in conventional shoe design, be aware that you need more thickness. It's important to know. Fourth, material thicknesses can steer the softness or the rigidity of your design, and this also in a gradually shifting way. And fifth up, last but not least, using 3D scanning data can really customize the design on every foot you can think of, and this is going by far beyond any fitting method that conventional fitting would represent.
All right, good. Thank you very much, Stephan, for all the explanation given. To being very honest with you, when we promoted the shoe, so the Cryptide shoe design, it raised a lot of international attention. We received many comments on social media, and I think it would be more than fair to answer some of those. So let's check out some of the comments we have received through the social media channels. All right, so we received a comment from Simon. Sintratec, during the British Science Festival in 2019, I was lucky enough to have an interview with BBC Radio Coventry. The topic was around TPU and its uses. The last question from the presenter was about the future of TPU, and I answered by saying there will be shortly come a time when you will be able to print your training shoes at home. You would buy the drawing like you do with architects and select your colors and hit print. Seems like we are getting even closer to that. What do you think, Stephan?
Yeah, if you compare it to the... you need a 3D printing system to do so. Printing TPU can be done in FDM systems. Is it suitable to print shoes in FDM systems? I think I saw some, which were amazingly good, right? So I thought it was amazing for haven't thought that FDM could do this. I would go for an SLS system at least, and this is something that maybe not everyone will have on his desktop at home. For most systems that are big enough to have a build volume big enough to print shoes, right? So sure. We are getting closer. These machines are getting more affordable when you compare it to, let's say, 10 years ago. Yes, maybe in the future. Yeah.
Sure. I see one personal story that I can tell. Last year I bought a new running shoe. It's not the most of the state-of-the-art shoe, but when I went to the retail shop, they first of all scanned my feet. They checked out where the pressure points are from my feet. They then individually tried to consult me by passing the best possible shoe to me with an inlet that makes it easier for my back to relieve when I'm jogging. So this is something that is not particularly very new, but if I see an outlook, maybe in 5 to 10 years, as you said, the machines are getting more affordable. The technology is getting more advanced. I mean, why not being able to scan the 3D model of your feet in a retail shop? Then at the end of the day, you go shopping, maybe in 2 hours, the shoe is printed. You can try it on. If some mistake happened or the shoe is not perfect, you can do it again. Will of course raise the costs, but for an individual shoe, that would help me, to increase my performance, to relieve some kind of back pain with jogging or any other thing that can occur for the knees. I would be personally absolutely willing to pay, I think, $300 to $400. The shoe that I bought was $216 or $60 or something like this. So it's not a cheap shoe, it's a very good shoe, but it's not the end of the road in terms of customization, I think. Where it comes down to the difficulties is maybe, coloring, what color do you like, what post-process is coming as well. But I think with the figures that I mentioned at the beginning, the business is so huge that even the disruptiveness could be possible. Because more and more companies will see, I think, the demand on customized shoes for sports people, for amateur sports people, for people who are having health issues. I think it quite goes into this way, and I would be astonished if not companies are investing in these possibilities. All right, so let me ask you a second question from Damien, if you agree, Stephan. Really creative and interesting design. What about the stability during the walk and the durability?
We have to be honest, it needs further testing. So walking around with this shoe like this, seems to work pretty good, but yes, it is. It's a fresh design, so we need to test more and more to see how long it really lasts. But one thing is also for sure that also conventional shoes are not lasting forever.
That's correct. And maybe one personal story as well. I was lucky enough to wear a different 3D printed shoe out of Sintratec TP for a video campaign we did for a shoe design contest as well that we launched at the beginning of this year. And I walked with such a shoe. And it was more than astonishing to me that it was very comfortable first of all. But I just walked 50 to 100 meters. Of course, as you say, more testing is needed. But I think as with any other design, it's part of time until it becomes more and more better, even better, and industrialized.
Yeah.
Okay, good. We have Timur, who asks us the following. Nice to see how a complete shoe can be manufactured out of one material and manufacturing process run. 100% recyclable TP and very practical as well as attractive design. Respect to Stephan Henrich and the Sintratec team, thank you very much, to show use cases with such a unique, easy to process TPE with high mechanical properties. Okay, I think that's not a question, that's more a statement. So if you have anything to add here, Stephan, feel free to do so.
Yeah, he mentioned a good point. So there's no glue added in this shoe that is holding different kinds of material together, that when you want to recycle it, maybe you have to put the textile in this bin, the next leather in this bin, the sole in this bin, if you want to do it properly. It's really just one material that is a pure material. There's only TP. It's a thermal process in sintering the powder together. There's no binder or anything added. So it's this is a selling point, and in our times, not the least important, I think.
I think so, yeah, more and more important. All right, so let's skip to Thomas. What is the advantage for the customer besides of crazy new looks and the high price?
If you can afford the most expensive shoe, why buying the second most expensive shoe?
I mean, that's correct. Some of the points I already mentioned. So whatever is even more customized to your specific feet and the needs that you're having is definitively, in my perspective, can prove me if I'm wrong, Stephan, worth to pay more money for it than for a standard shoe design that is maybe not, it's much cheaper maybe, but it's not solving all of the issues that it could. So full stop. This is my feedback.
Mm-hmm. Yeah, I would say if you really go for something highly customized, it can even go beyond customizing. It can have a orthopedic aspect to it. Maybe you have a headache using everyone knows, many people know, using the wrong shoe can give you a headache, and beyond that. And if you have shoes really customized to your way of walking, actually everyone has a special way a very personal way of walking. Then it's maybe worthwhile spending more money.
Absolutely. Just one thing that came off the top of my head, for very, very tall people with huge feet, there's not always the size of the shoe of a standard shoe that you can buy. Maybe this is one other interesting field, to solve issues for people who cannot afford shoes that are easily worth than $1,000 to $1,500 for their size. So I think there is maybe a demand as well. All right, let's move to Carlos. That is indeed a great demonstration of design capacity, functionality, integration, and manufacturing process knowledge. Congratulations. Thank you, Carlos.
Thank you.
However, apart from leaving a weird trace behind you, as the designer says, I am not sure if the functionality responds to current users' needs. Like extra comfort, improved grip on sand, ice, or climbing, specific corrections or others.
Carlos, I saw your comment. It's true, weird traces. No, I think what you are asking for would be a shoe that is usable in every condition. So sand, ice, or climbing are very diverse fields of use. know. So yeah, I'm not sure if this is too much expectation for this specific design.
All right, good. So full stop, nothing more to add from my side. All right, the last question I collected and prepared comes from Kyle. Those look like they'll give you the worst blisters on your Achilles. All right, Stephan?
I want to answer, hopefully not. But I think it's in the state between a design vision and a technological vision, a prototype, which is for sure variable, but I agree. If it turns out that it's not comfortable in one spot, we have to change the design a little bit, which is actually not a problem, and it's the same you would do in a conventional design process as well, no?
Absolutely, and I think it's not the end of the road. I think it's a step further into industrialization. Definitely not there. This will take some more years to do so. But yeah, so with this, I would like to thank you for your insights and your time today, Stephan. I hope it was a pleasant tech talk for you as well.
It was. Thank you for the invitation. It was fun.
Sure. We are looking forward to hear and see, of course, more of your fantastic designs in the future. Is there any outlook, what we can expect from you in the future? Any words from your side?
Actually, right now I'm busy working on a robot, a climbing robot, all done in SLS. Maybe in a few weeks I can show you more.
Great. So in the meantime, if anyone of the audience who is maybe listening or watching this tech talk has design questions or needs design support, we will put the address of Stephan in the comments section. And Thank you very much for hopefully enjoying this tech talk with Sintratec and Stephan Henrich. It was our pleasure, and stay healthy as well as having a great rest of the week.
Thank you everyone for watching.